welcome to the channel. Today, let's talk about Aryabhata, the ancient genius who changed the world forever. And for talking about him, we obviously have none other than Mr. Radhakrishna Varyarji. Hello, Radhakrishna.
Namaskar.
All right, let me introduce Radhakrishna ji real quick. So, Radhakrishna Varyar is an engineer by profession and is deeply interested in such non engineering subjects as ancient science, modern science, history, linguistics, astronomy, and anthropology as related to Bharat. Originally from Kerala, India, Radhakrishna ji obtained his bachelor's degree in electronics and communication engineering half a century ago and immediately afterwards joined the Indian Space Research Organization, which is more known as ISRO, as a young engineer. After working at ISRO for 21 years in the field of radio frequency and microwave communication as related to satellites and launch vehicles, he continued his career abroad. He obtained his master's degree in engineering in Dalhousie University in Halifax, Canada. After working for many years in Canada in the same radio frequency and microwave communication field in different companies and in different cities of Canada, he came to the US about 9 years ago. He has been living with his wife in the city of Renton for the past 8 years and has been working in the field of radio frequency and microwave communication for positive train control, which is known as PTC. His son, daughter in law, and two young grandsons live in Halifax in Canada. Welcome, Radhakrishna ji.
Namaste all.
So, Radhakrishna ji, you have been on the show a couple of times, and we really appreciate your in-depth knowledge about so many topics. Today's topic is very, very dear to my heart. It is on Aryabhata. And let me tell you a quick story of how I came across Aryabhata is I had a school field trip which was planned in Ayuka, Pune. Ayuka, Pune is a center known for astronomy, the field of astronomy. And there I saw a statue of Aryabhata, and I asked my professor who this statue belonged. Who is this person? And they were like, "Oh, you have to speak low. People will get offended. This is Aryabhata, and he has a huge contribution to the field of astronomy." So this is a very at very young age I came across Aryabhata, and I started reading on him. Primarily on his work of Aryabhatiya, but I should confess that I hardly understood about 30% of that book. So I think it's deeply technical, right?
Yes.
Yeah. So just to give the viewers a little bit of idea, Aryabhata's work has been, there is a lot of work that we have already lost. The work that we know, which is Aryabhatiya, is divided into four sections. First is Gitika Pada, which is introductions to measurements and units that he has used throughout his work. There is Gola Pada, there is Ganita Pada, and then there is Kalakriya Pada. So we'll talk about all of this with Radhakrishna ji today. So let's kick off this conversation. So first of all, Radhakrishna ji, you introduce us to Aryabhata, please. Who is Aryabhata?
See, Aryabhata is the foremost among our ancient astronomers and mathematicians, and his biggest contribution is nothing. Nothing is what? It is zero. So he was the first person in the world who used and the place value system, decimal place value system with zero. So that itself is a great contribution to the world, to mathematics, astronomy, to all fields of science.
Yeah.
Then again, he said that the Earth rotates on its axis, which is great because till then people were thinking that Earth is stationary and everything else revolved around it. And of course, he knew that the Earth is a what do you call spherical thing,
Yeah.
what they call gola in Sanskrit, and he said that all planets and everything is gola.
Okay.
Which is true.
Yeah. That's also huge because I feel like being here on Earth and just having observational astronomy, it's very hard to say that I mean, knowing about Earth, I can still understand that Earth is spherical. He might have his genius to detect that, but also to know that other planets are round. Sun you can see is round, moon you can see in phases, but there are other planets that are They almost look like stars when you look at them in the sky. But he already knew that those were also
Yes.
round in shape, which is huge, I feel.
And his actually his legacy is uh, long lasting. He left a lasting impact
Mhm.
for the entire Asia and also for the entire world. And you know that till very recently, it is his methods that were being used by our Indian panchangas and in Indian astronomers. And
Yeah,
till about 18th century, most of his methods were used by foreigners also, Arabs,
yeah,
Western astronomers.
right. I
Like
think
Arabs used the longitude of Ujjaini. You may wonder. Okay, we'll come to longitude, etc. later, but mm, they used the longitude of Ujjain for their calculations.
right. And I think he's also been very specific about when he has written his work. We'll come to that as well. And like you said, Arabs have been using it. I think there's a book from a traveler in 1000 AD, or 1000 Common Era, I should say, which is called Al Baruni, and his the diary related to his travel. So he mentions a lot of astronomy which he learned from India, or rather from people of India. And I feel like that as well depicts a lot of what flew from Aryabhata's teachings. And Aryabhata
Right.
has existed from like 476 to 550 Common Era. So I'm assuming that his methods and his work were followed by his students and followers, and eventually reached Al Baruni, and we also know about that.
Yes.
Excellent. Okay, so let's talk about his work. What did it compose of, and let's also talk about where he wrote it.
Yes. It's quite interesting. His m- magnum opus, or his most important work, is Aryabhatiya.
Mhm.
And he obviously composed many other works, but they are all lost in time. We have only received Aryabhatiya. However, his other works have been quoted by other astronomers and mathematicians. So, certain passages, certain shlokas have been quoted by others, and these actually inform us that he had composed many other works, and especially his Aryabhata Siddhanta.
Yeah.
So that work, however, unfortunately, they have not reached us, but
Mhm.
parts of that we know through these other astronomers.
Right.
Now, when did he compose Aryabhatiya? That is interesting. He says in the beginning itself
Mhm.
that he composed Aryabhatiya when he was 23 years old. At such a young age, such
Yeah.
a masterpiece.
Yeah, absolutely. So I should tell the audience that Aryabhatiya is a work of 121 shlokas, and these are divided into the four sections that I talked about earlier. There is Gitika Pada, which is the introductory part of what his work is going to be, and then there is Gola Pada, Ganita Pada, and Kala Kriya Pada. We'll see what these are in a short
Yes.
while. But composing this at the age of 23, and also noting that down, because he has mentioned the reference saying so many years have passed since he was born, and now he's
Yes.
writing Aryabhatiya. So he gives clear reference of when he's writing his work, and we can begin to appreciate his genius at the age of 23. I don't think I was doing anything substantial when I was 23. So let's dive into the details of Aryabhatiya. So, like I said, I think Gitika Pada is more about the introductory part, but Radhakrishna ji,
Yes.
you can explain more on what else he
Yeah.
has in mind.
Gitika Pada has 13 slokas, 13 verses. It is basically definitions. He starts with the definitions. It includes definitions of his number system.
Mhm.
Then it includes units of time, circular and linear measurements, details about rotation of the Earth. See, he
Mhm.
was the first astronomer who said that the Earth rotated. That's also important. So, rotation of the Earth, and also revolutions of the celestial bodies. And it discusses measurements of all these, their orbits and all that. That's all deep, what do you call, trigonometry and mathematics. Then he goes to Ganitapada. Ganitapada consists of 33 verses. Again, it deals with mathematics. It covers geometrical figures, their properties, mensuration, problems related to shadows of gnomons. Gnomons were used in the olden days for measuring time. Their shadow would tell that to time. So he used those. So he explains the maths of the gnomons. That's also not trivial. It is fairly involved.
I am sure
And
because
then
anyone who
yeah,
attended our Leelavati, I think that had the gnomon shadows and the mathematics related to that, right? And that
yes,
was even
yes,
in
yes,
12th century questions. So
yes,
this one is even way before.
yes. And then it includes equations and all that, solutions of equations, and extracting square root, cube root, and such things.
Yeah.
Then we go to the Kalakriya Pada. Kalakriya Pada had 25 verses, and it uh, focuses on the units of time and the positions of sun, moon, and the planets. It describes the divisions of the year, month, and day, beginning of the time cycle, and motion of the celestial bodies. Of course, see, he subscribed to geocentric model. We'll come to that later. So this also describes the epicycles and eccentric cycles and all that. Then it provides methods for computing the true longitudes of the sun, moon, and planets. Here, longitude is not the longitude of the Earth, but longitude of the celestial sphere. So, and then comes the Golapada. Golapada is mainly about astronomy using Gola, which is spherical trigonometry, actually, and it has 50 verses, and it describes motions of celestial bodies, and it describes various circles of celestial sphere. See, celestial sphere is divided into various circles like ecliptic, then again longitude, right ascension, declination.
Yeah.
These are all technical words. So they all pinpoint the position of heavenly bodies. So it describes all those things. It also includes rules for spherical astronomy, which is spherical trigonometry.
Mhm.
Yes, Panditji is saying Ujjain is the prime meridian. Yes, it was.
Yeah.
And what is this lady doing here?
Yeah.
This lady was generated by AI, artificial intelligence. I just asked it to create a picture of
Mhm.
a contemporary Gupta princess. See, Aryabhata lived in the Gupta era. So at that time, Gupta kings were ruling. So I
Mhm.
just asked artificial intelligence to draw the picture of a Gupta princess going through Aryabhata's works. And that's what she's doing.
I think
And
it's
also, I have to say that in the olden days, women were well educated, as Shruti will know that.
yeah. Yeah, of course. I think from what I read, especially for prince and princesses, I know everyone was learning at the time, but specifically for prince and princesses, they used to teach them 64 arts, 64 types of arts, which is called as Sausashtakala. And so in that, they would teach them to cook also, to dance, to like study mathematics and astronomy. And I think this 64 things that they are talking about, it makes sure that the prince or princess are living a successful life. So one would think, why would a princess want to cook? Because she would have an entire crew with her, right? But we have our history of Sita and Draupadi who had to flee to the forest and they had to manage everything on their own. So how do you do that if the time comes? So I feel like that's the reason that the prince and princesses were so well taught, and I'm pretty sure the entire society was extremely well versed with common things. For example, the knowledge that the earth is round was pretty common after Aryabhata. It's not like it was constrained within a specific class of people. everyone knew that, everyone knew how to apply it also. I remember there was also another session that Radhakrishna ji and I did on astronomical instruments built
Yes.
by all these great scientists, and they were so simple that anyone could make it and anyone could use it. It's not like you have to go somewhere to get the specific apparatus or anything like that. And you could easily apply this knowledge of based on stars which direction is where, based on the shadow of the sun, what direction are you going towards. Whether you are navigating in a boat or you're walking, you would know what direction you're going in without having to use a compass. So I think all this knowledge was very, very common knowledge. Everyone knew about it, and no wonder that AI generated this kind of image, because AI knows. Awesome. So let's talk a bit about his work itself. So, like I have said this in the past, that it's hard to follow Sanskrit these days, unfortunately, because not everyone is well versed in Sanskrit. And I also feel like someone who is like Aryabhata, who has given his entire work in 121 verses in Sanskrit, I think it's hard to fathom so much information and also understand it. Like I said, when I read Aryabhata, I could barely understand 30% of it. And I was a mathematics student at the time as well. So, from you, Radhakrishna ji, I would like the audience to know, like, which work that they can depend on if someone's interested in going ahead and reading on Aryabhata. Where should they look for?
Yeah, sure. Actually, you see, Aryabhata composed his work in such a way that all the verses are very crisp and what do you call cryptic. Okay, and why did he do that? See, most of our ancient scientific treatises are very crisp and condensed. So why do they do that? Because they wanted the students or others to memorize that, to keep it in memory. It is easy to memorize words,
Mm,
what do you call, succinct, cryptic verses than lengthy uh, prose. So
mm,
explanations were done in words, and
mm.
they were very brief, very cryptic.
Yes.
So so when a cryptic verse is there, especially in Sanskrit, it's a little difficult for anybody. See, even in the olden days, they composed bhashyas.
Mm,
Okay, bhashya means commentaries. They
mm,
had to compose commentaries, and many people did that. Bhashyas in Sanskrit, bhashyas in regional languages, and the important bhashyas, the most important bhashya was by Bhaskara I.
mm,
Bhaskara I lived just 100 years after Aryabhata, and he was, means, he appreciated Aryabhata very much. He was a, what do you call it, disciple of Aryabhata. So his bhashya is very important. Of course, that's in Sanskrit. Then much later, another exhaustive bhashya was by Nilakantha Somayaji. He's
mm,
from Kerala. He lived in the Middle Ages, like 1465 CE. Then older bhashyakaras, means those who composed commentaries, were like Prabhakara, Parameshwara, Someshwara, others. Then our Bhaskara too of Leelavati fame,
yeah.
he quotes extensively from Aryabhata. He was also a very staunch disciple of Aryabhata.
Mm,
And now, of course, we have to depend on English translations.
mm,
So the one that I used, I have shown here, I have given the link here. It is Aryabhatiya of Aryabhata
yeah.
by Kripashankar Shukla and K.V. Sharma. They give the Sanskrit original.
Right.
They give the meaning and explanations, very deep explanations. For one shloka, they devote like 2-3
Page.
pages. So I means whatever I understood from this book.
Yeah.
That's great. Then there are other reference material. I have given them at the end. I have compiled all in a slide, and they'll be very useful.
Right. And for audience who want to get started, get inspired from this session, I should say, and then get started reading Aryabhatta, you have this link right here. We'll also share it in the comments and descriptions as we go. So also remember that, a lot of people have talked or have commentaries on Aryabhatta, but there is always a good starting point, like Radhakrishna ji said. So we'll have a list for you at the end, but this would be a very good source to get started. Meanwhile, I do want to highlight some of the things that Pandit Mahesh Shastri ji is saying. So he's saying women in India were very learned, study. They used to study Yajnavalkya Gargi Samvad. There was also Maitreyi Samvad from what he's saying. And there was also, yeah, I think I'm aware of the story of Madan Mishra's wife was a judge in the discussion. So
Yes,
between, Shankaracharya and Madan Mishra, and there is a picture where she is standing in between them trying to judge
yes,
between these two great scholars on their commentaries. So I feel like that's a huge deal. There is also someone saying here, Vidishri is saying, please share the link in the comments later. Of course, I will. All right, so let's also dive a little deeper into the topic of astronomy and astrology. So Radhakrishna ji, from what I understand and what I've read all these days, in pre-colonial times or before the British came to India,
yes,
what we had as the entire study of Jyotisha Shastra is astronomy, which is Khagol Shastra, along with astrology, which is now we call it Jyotish Shastra. So these two things they were under one umbrella. They were not like looked at it as this is
yes,
astronomy and this is astrology. They were together called as Jyotish Shastra. And no wonder, because for astrology part where you are predicting how certain planet will affect your life, you first need to know everything mathematically about that planet, where it is, how far from Earth. There have to be
yes,
calculations, panchang, all of those things. So it does make sense to me. And together, Jyotish Shastra was called as Vedanga. So it's like a limb of
yes.
Vedas. And so I am curious to know whether Aryabhata's work is more focused on astronomy or astrology or both.
Actually, Aryabhata's work is fully focused on astronomy. He
Okay.
doesn't mention the astrology part.
Okay.
So, but there is one verse that says about the lords of the hours and lots of the days of the week, say like Somawar or Mangalwar. So there, the lord of that particular day is that planet. So he describes that, but he doesn't say about the consequences.
Mhm.
So uh,
Yeah.
it is just the science of it.
Right.
He is not dealing with the astrological part, means about the future, about how these things affect our future and all those things.
Right.
Then what our astrologers used to do is they use Aryabhata's principles for calculating exact location of all these heavenly bodies, and
Mhm.
then they use other texts for their astrology
Part.
part, which is
Right.
good. So they get the right positions of the heavenly bodies, and from there they can do their astrological work.
Makes sense. Of course, and I feel like anyone who is a good, astronomer and astrologer, like Pandit Mahesh Shastri ji, for example, he will also say that astronomy is the foundation for astrology. You cannot think of just astrology as a field, like predicting, because first you have to know positions of planets precisely to be able to
Yes,
say whatever the effect that they'll have. So no wonder Aryabhata's work was used by so many astrologers for the precision part of it. I should mention to the audience that Aryabhata was also the head of department in Nalanda University. Am I
yes,
right, Radhakrishna ji?
yes,
And
yes, you are.
he was extremely focused on being accurate about things. So being accurate and precise is a pattern all over his work that we'll see. So one quick thing before we proceed into his work further, Radhakrishna ji, his name, right? There's a lot
Yes,
of controversy on whether it's Aryabhatta, which is more with a double T, and then there is Aryabhatta, which is
single
softer.
T.
Yeah. So how, like, what is his name, or do we even know how to come to
Yes,
the conclusion of that controversy?
yes. Actually, in the very first uh, shloka, in the very first verse, he gives his name, and he gives his name as Aryabhata with a single T. And then in later in another shloka also, he gives his name as Aryabhata with a single T. Now, you might ask, it could be a mistake or something, but if you substitute the name with double T, it will not match the meter of the shloka. Meter means vritta. We call it in Sanskrit as vritta. So it will not match the vritta. Now you come to others. Others have quoted Aryabhata's works. So there, these others also quote the name as Aryabhata. Now, if you try to substitute it with two T's, it will not match the meter. So
Right.
in Sanskrit, matching meter is very important. See, there are so many vruttas, like say uh, Arya Vratta, Geetika Vratta, Shardula Vikridita. So many vruttas means meters, and uh, shlokas are composed to some of these vruttas.
Right. So
So
what
here, the
Radhakrishna ji, to be more clear to the audience, what we are saying is if you replace it with double T, then
yes,
Sanskrit language does not allow that. Basically,
yes,
it will basically evade the rules of Sanskrit, and Sanskrit does not
yes,
allow.
yes,
So I, from what I know, a lot of verses in Vedas also, they follow that specific pattern or the grammar rules that Sanskrit has set, and so it is almost impossible to twist them or change them and make them sound something else, because of the rules or the way that Sanskrit is organized. I think it's not possible to do that.
right, exactly.
Mhm.
And the meaning of Aryabhata is a noble warrior, a noble soldier. Bhata means a soldier, Bhatta means a learned man. So
Oh.
here, probably his parents wanted him as a noble warrior, blazing forth uh, trails in the field of knowledge. And
Yeah.
if and if that were the wish of his parents, he has amply fulfilled it.
Yeah, of course. Yeah, I think he basically did that way better than anyone else would have.
Yes,
Awesome. So, other question or controversy is also about his birthplace, I think.
yes.
Do we have any conclusion on his birthplace?
No, there is no consensus. Actually, Bhaskara too says that he was born in Ashmaka, but where is Ashmaka? See, people like me will say it's in Kerala.
Yeah.
Others will say it is in uh,
Yeah.
Bihar or in Bengal. Or so there is no consensus. But there
Mhm.
is consensus that about his uh, place of work,
Mhm.
and that is Kusumapura. Kusumapura is Pataliputra, which is same as modern Patna in Bihar, and
Mhm.
also that he worked in Nalanda University. There, Nalanda is very near Patna, so he worked there,
Mhm.
and also he himself has said when he was born. He says that he was 23 years old when the Kali year was 3600. From that, we can easily say that he was born in 476 CE. There is a common era. And
Mhm.
also, uh, it is believed that he was born on the Mesha Sankranti, that
Yeah.
is noon of March 21.
Yeah. And
In Mesha Sankranti is when the sun enters the Mesha Rashi.
Raj, yeah. So that's the zodiac or constellation out there where
Yes,
sun is entering, as observed from the Earth, and
yes,
that is when he is believed to be born. So for audience not to get confused with Kali Yuga or starting of Kali Yuga, I do want to mention, just so you know, that as today, because of the way that the West has taught us, we kind of know everything in like we believe current year to be 2024 common era, or after that zero point that we have. So likewise, there was a calculation for in India for which we came up with ourselves, and that was the calculation of yuga, which I think again Aryabhatta, or the genius of Aryabhatta, has also mentioned. how to measure that time, and he's also talked about immeasurable time and measurable time. So measurable time being day, night, years, and yugas, and so on.
Yes.
Immeasurable being, we don't know everything, or when
Yes.
Big Bang happened, or those things. So that's the immeasurable time. He's talked about both. But at the time Kali Yuga, everybody knew when the Kali Yuga has started, or when that time has begun. Like we know the zero today. And so that he has said that 3600 year, he's 23 at 3600 years from the beginning of Kali Yuga. That's how we know that he's 23, because we also know his birth date. So he was also Kulapati, like Radhakrishna ji said, at Nalanda University. No wonder he was very, very specific on accuracy and precision. I am not at all surprised with that. Also, let's talk about, I feel like all these great scientists, one common thing that I observe in them is humbleness, or being very, very grounded. Like, they don't
Yes.
think, Aryabhatta doesn't think he is the greatest, whatever, the astronomer. We are saying that about him, but I don't think that is how he was brought up. So let's talk about that a bit. Where do we see that, Radhakrishna ji, that
Yes.
he's being very, very humble at the beginning of his work?
His first verse itself, he says that he's paying obeisance to the ultimate reality. That is the Param Brahma, and that is one and many, means that is beyond all qualities. It is the what do you call, nirvikalpa nirguna parabrahmam.
Mhm.
So he is paying his obeisance to that ultimate reality, which is the existent truth, which is the truth
Mhm.
according to him. And then he says that Aryabhata sets forth, means he is going ahead with the three. And what are the three? That is mathematics, reckoning of the time, and the celestial sphere, the
Yeah.
gola.
Mhm.
So he is paying obeisance not to a Saguna Ishwaras. Saguna Ishwaras are what we think about, like Lord Krishna, Lord Rama,
Yeah.
etc. They are with gunas, but he is paying obeisance to a Nirguna Parabrahmam. That's why he says Eka and Aneka. It
Yeah.
is simultaneously both.
Yeah, I think Ishanya Upanishad also talks about that there is saguna, like you said, there are deities with qualities, but there is something which is beyond that, which is just power. It's very hard to fathom, or begin to fathom that power, because it can be one and many at the same time. It's in past, present, and future at the same.
Yes,
It doesn't make any, it makes it very, very hard to understand that power. But that is
yes,
what we call Parabrahma or Isha, the one
yes,
before everyone else, and the one who will be after everyone else. And I feel like that is what Aryabhatta is bowing down to, where we are saying that's the eternal truth, that's the reality of everything. So he is being extremely humble. He's first bowing down to the eternal truth, and then he is beginning his work, which is, again, I find it extremely nice, that that's a quality that every scientist, or anyone who is great in any field should have. They should always be grounded and down to earth. And let's
right.
also talk about, I am extremely amazed at this, Radhakrishna ji, that there is a concept of latitudes and longitudes in his work, which today
Yes.
we know because of Google Earth. Otherwise, I don't think we would know about it. But let's talk about how, in the era of Aryabhatta, how do we know that we know about latitude and longitude?
Oh,
First thing is that, yeah.
yeah, actually, that's great. He describes longitude and latitude of not only Earth, as I said, but about the gola, about the celestial sphere. And what is the longitude and what's the latitude? See, when we come to Earth, if you see the picture, the vertical lines are longitudes. They're actually semicircles when you see the globe. So those are longitudes, and the parallel circles are latitudes. Now, why are they required? They are required to pinpoint the position of any place. So it is a coordinate system. Just as we have XY coordinate system,
Yeah.
x axis and y axis, this is as similar. So this coordinate system allows us to pinpoint a place on Earth.
Right.
Now, equator is the 0 degrees latitude,
Mhm.
and the other latitudes are parallel to equator.
Right.
And longitudes, again, you can actually choose any longitude as the 0 degrees
Yeah.
reference. And in the of course, now it is Greenwich,
Mhm.
passing the longitude that passes through Greenwich is the prime meridian. Prime meridian means zero degrees. But this was chosen only 150 years ago.
Yeah.
Till then, Ujjaini is modern Ujjain. So modern Ujjain was the prime meridian of our ancient astronomers. That was the 0 degrees longitude.
Yeah.
And interestingly, see, Ujjain is not on the equator. Ujjain is on the Tropic of Cancer.
Mhm.
So they also wanted, means the 0 0 will be on the equator, means 0 latitude and 0 longitude. So the that place, they chose a fictitious island called Lanka. It's not our Sri Lanka. It's a fictitious island, Lanka. So it is easy to say Lanka rather than origin 0 0. So just they named it.
Easier.
That's all. So
Yeah.
this is what is shown here.
Right.
These pictures, they describe the longitude and latitude.
Yeah. So to explain a little bit more for the audience, try to understand this that longitude are these vertical lines and latitude are these horizontal lines, like we said. Now, if you want to have so anything which is on this prime meridian, which is the center of longitudes, and the equator, which is the center of latitude, then you want to choose something which is matching both of these, and then it becomes 0 0. You can imagine that Ujjain, that Radhakrishna ji was explaining, is on one of these vertical lines, and Indian astronomers considered that to be the y-axis 0. But for x-axis 0, India does not have any land on the equator. So we are right above that equator line as far as Indian subcontinent is concerned. So since we didn't have anything, there was a need to have a fictional or like an imaginary island there, and then consider that as 0 0. The point to highlight is they knew that we don't have a line on the equator, and they knew to consider a 0 0 reference of a fictitious land. Coming to
Yes.
the word Lanka, Lanka actually means marshland, just a marshland which is surrounded by water. So we know of Sri Lanka, which is also a marshland. It's an island and it's surrounded by water. But this fictitious Lanka doesn't exist. We had to have this in the calculation so that we have a land which is lying on the line of Ujjaini, but it's also on the equator somewhere. It doesn't exist for India, but we had that as a point of reference. So I hope
Exactly.
that clarifies it a
Yes.
little bit.
Yeah,
And
yeah.
then
That was a nice description. Yes.
Okay, and today for today's calculations, like Radhakrishna ji said, we have Greenwich, which falls on the equator, as well as it kind of has both of those things, and so it's considered as 0 0. One more fun fact about Ujjain is that Ujjain also has some temples which are dedicated to planets. So now it makes sense that why Ujjain would have a Mangal temple. There is a temple of Mars in there, and if somebody has Mangal dosh, they would go and perform puja there. And so it now makes sense why Ujjain has that, because Ujjain was the center of astronomy for a very long time in India, and also considered as 0 reference point for the longitude part of it. So now moving ahead,
The
let's talk about
the 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 interesting part is that even Arabs used
Ujjain.
the longitude of Ujjain as their prime meridian.
Right. So they also use 0 reference for Ujjain and did their calculations on their side. Okay. So now talking about, knowing that the Earth, like we already said, Aryabhata knew that Earth is round. Let's talk about, how he knew about Earth is round, and also how we know that he knew that the Earth is round, and also about the time. I think he was extremely aware that as you move up the longitudes, your timing is going to change, or time zone is going to change,
Yes.
which is again extremely it leaves me awestruck that he knew that.
Yes, yes. See, actually, when people were thinking that the Earth was flat, Okay, our astronomers were dealing with the spherical trigonometry of the globe, of the Earth as a globe. Okay, and another interesting thing is that Aryabhata knew. See, the time changes with uh, longitude. Right now, we are in Seattle, and somebody in India is almost 180 degrees, and we have about 13 and a half hours difference. So, somebody in London, England will have another time. Somebody in Australia will have another time because the latitude changes. So, Aryabhatta knew this very well. So he says that when it is sunrise in Lanka, again, Lanka is 00 reference point. When it is sunrise at the reference point, it is sunset at Siddhapura, which is in the next sloka. He says Siddhapura is 180 degrees on the other side, uh, again on the equator. So this is likely a fictitious place.
Yeah.
Then midday at Yavakoti and midnight at Romaka. But they may have real counterparts. For example, yes, you can take any city as the prime meridian. So he very clearly knows that when we change the longitude, when the longitude of a place changes, its time also changes, its local time also changes.
Right.
So we're very clear.
Right. And here is the midnight and Romaka. Romaka is Rome, is it? And
Romaka might be on the longitude of Rome, but again, it is on equator. Just like Lanka is on the longitude of Ujjaini,
yeah,
but on equator.
right.
So
Yeah,
these are all fictitious places, but
right.
they could be counterparts of real cities.
Yeah, I think there is a mention of Yavana is also, I think, side of Greece or Rome, and then
This Yavakoti is on the other side.
other side. Okay.
Romaka is on the actually Romaka could be on the longitude of Alexandria.
Oh, I see.
Alexandria was a center of astronomy. It means Greeks were there. It is in Egypt, but Greeks were the main scientists there.
Working there. Yeah. So he is also aware of this, the difference of 0 degrees and 90 degrees and 180 degrees and 270, and how that affects the time zones. That is also something that he has mentioned in his verses, which is again insanely amazing. Let's talk about all these great scientists like we saw in Leelavati as well. Bhaskaracharya has beautifully put the mathematical problems in nice Sanskrit
Yes.
proses, and so I feel like all these scientists are extremely well versed in language as well. In today's day and era, we feel like, oh, a person can only master one field, like they were great scientists, so it's obvious that they don't know the language much. But it seems like all these scientists were great at scientific fields, as well as they are amazing at putting or using language to make all of their work very very precise and easy to follow through. So do we also see some poetic references from Aryabhatta when he has composed Aryabhata or any of his work?
Oh yes, definitely. See here in Golapada, verse 7, it is beautiful. He says, just as the bulb of a Kadamba flower. Kadamba flower is very much used in our Indian poetry. It's a very fragrant flower and beautiful. So he says, just as the bulb of a Kadamba flower means just as it is covered all around by blossoms, just so is the globe of the earth surrounded by all creatures, terrestrial as well as aquatic. Aquatic means water creatures. So
Yeah.
he is comparing the earth to the kadamba flower, and
Mhm.
which is covered on all sides by blossoms, and creatures like us are the blossoms of the globe of earth, of the kadamba uh, blossom that is earth.
Right. That
That's,
is so beautiful because I feel like this also talks about coexistence, right? We are all
yes.
coexisting on Earth. And, he's not making it purely of just the spherical trigonometry and the depth of it. but also
Yeah.
comparing it with something as beautiful as Kadamba flower and talking about how we all coexist on the same in the same place. Okay, so we did say that he knew about rotating Earth. So let's talk a
Yeah.
little bit about that, because that's, I think that's very unique. I think we have had scientists from the West who are also talking about Earth being spherical or circular, but much later, obviously, as compared to Aryabhata. But there is also rotating Earth, which a lot of people were not bold enough to say that out loud. So
Exactly.
Aryabhata not only knew that, he also gave like scientific proofs stating all
Yes.
of that. So let's talk about that a bit.
Yes.
Mhm.
Of course, when he said that the Earth is rotating on its axis, many disagreed. But in India, you will not be punished for anything like that. People will say, I disagree. This is not the correct point of view.
Mhm.
That is the in the spirit of the debate, in the spirit of scientific inquiry. But
Mhm.
you will not be put in a prison for saying that the Earth is rotating. So, uh, famous astronomers like Brahmagupta and Varahamihira differed with Aryabhata. They said it's not rotating, whereas others agreed. Even Bhaskara one, he agreed. Then these others, they also agreed. There were many scientists who agreed with Aryabhata, and many who disagreed. So it is the spirit of science
Right.
debate.
I'm sure it is evident, Radhakrishna ji, because I have heard about so many conferences also being held by different kings where the scientists and the scholars are just invited to debate. There is
Yes,
no, like, I don't think there is something like you have to stick with one thing or one side or
yes,
whatever it is, right? And
yes,
I'm sure like there are mentions of that everywhere. So
yes,
I'm not at all surprised that in the time of Aryabhatta there were other scientists who disagreed with them. They are also stating it out boldly, by the way, that they disagree with him. Although I don't know why, because if Earth is rotating, I think he
yes,
has like clear proof for that. But yeah, let's get into his details of
yeah.
proof.
And another interesting thing is that he actually measured the rate of rotation, and he said a
Mhm.
sidereal day. Sidereal day means when the Earth comes back to the same position with respect to stars.
Right.
So he measured the duration of the sidereal day, and he said it is 23 hours, 56 minutes, and 4.1 second. Whereas modern measured value is just 0.009 second
Yeah.
different from his value.
Right. I think it seems like he's just rounded it off
Yeah.
a little bit. So he said that it's 23 hours 56 minutes 4.1 seconds, whereas the modern calculation is 23 hours 56 minutes and 4.091 seconds. So
Yeah.
not only is he giving that in Kalakriya Pada, he's not just giving that the earth is rotating and just leaving it as a statement. He's also saying, oh, it rotates in such and such time and then comes
Yes.
back to the same position. So that's insane amount of accuracy. Again, like we said, he's extremely heavy on accuracy and precision. Here we can showcase that that is the case. So let's talk about
And
relative motion as well.
yeah, actually, he substantiates the rotation of the Earth with the analogy of relative motion.
Hmm.
So he said that when you travel, see, in his time, boats were the fastest way of travel. So
Yeah.
when you travel in a boat, you see the trees on the banks moving in the opposite direction. So he is comparing that to Earth's rotation. It is the Earth that is rotating, but we feel that it is the heavenly bodies that is going in the other way. Sun is
Right.
rising and setting. Moon is rising and setting. Stars are rising and setting. So we feel that, but actually it is us
That's
that
true.
are rotating. So that's what he says with this analogy of the relative motion of a
Yeah.
boat moving, and the passengers in the boat feeling that the trees on the banks are moving in the other direction.
Right. Yeah, this also is actually astonishing because I feel like in the boat, I definitely know I'm moving. I
Yeah.
started the boat and I'm making it move. Or, it's very hard because it's first of all, it's not moving with the speed that a boat would move. So you would not
Yeah.
know that whether Earth is moving or it's the stars that are moving. It's very easy to assume that the stars are moving, just because I feel
Yes.
like we all feel that we are stationary, we are not moving. So I'm again extremely amazed that he knew this fact, and he also
Yeah.
gave the details of, I think, what causes that relative motion also, right? He's
Yeah.
talking about pravaha vayu.
Yeah. Pravaha Vayu means the wind that blows. Okay. So they actually see it is, they didn't think that such a wind existed, but
Yeah,
it's again like the fictional, fictitious Lanka. This is a fictitious wind that moves everything. Right now, we know that it is gravity and all those things, but at that time, they had to have some what do you call
assumption.
theory. So they said there is a pravaha vayu, and that moves everything in the universe.
I see.
They knew that it is fictitious, just as the Lanka.
Right. And it makes sense because you don't know something, but if even if you don't know something, I think it's okay to assume that it's called
Yes,
something. So that
yes,
we are not, it's equivalent of saying it's X, I don't know
yes,
what it is, but there is something
exactly. Yeah,
making
give
that.
that X a good name like Prabha Vayu or Lanka.
Yeah. Exactly, that makes so much sense. All right. So let's also talk about the fictitious island of Lanka a little bit
Yes,
more. I think
yes.
we
So
explained in earlier that what that 00 coordinate would mean on Lanka, but let's see how he's used the concept.
yes, see, we have actually two motions. Earth is rotating, and also Earth is revolving around the sun in
Mhm.
a year. So uh, Aryabhata said that Earth is rotating, but he did not say that the Earth is revolving around the sun. Probably he knew it for his own reasons. He didn't say. So uh, for all these uh, astronomical purposes, he used the geocentric model with epicycles and eccentric cycles and all that. And again, coming back to other countries, even the Greeks and Romans, they also used all these epicycles and what do you call eccentric cycles. But Aryabhat, Aryabhata's methods gave more accurate results. Uh, and then, of course, we come to the Lanka, which is
Mhm.
that fictitious island, zero
Yeah.
zero, or origin of the coordinate system.
Mhm. Makes sense.
So
So this is also, I think, the fact that he yielded more accurate results. Does it have to do with the fact that he had that Lanka assumption of 00, where
that's easier. That is just for naming the thing. See, the origin is named as Lanka, which is easier in shloka, etc.
Mhm.
To say that instead of saying zero zero origin,
Yeah,
Lanka, just one word you say. So it is for the purpose of describing things,
yeah,
especially in verse,
okay.
in poetry.
Yeah, makes sense, makes sense. Awesome. So let's see about his instruments. So I think we have talked a
Yes,
little bit about this in the past, but
yes,
he had very simple apparatus for calculating the duration of a day. And there is this apparatus that we can see in this slide, which I'll let Radhakrishna ji explain it because it looks simple, but I think it's very complicated.
yeah. It's there. It's see, when people didn't know that the Earth rotates on its axis, he made a model of that Earth which rotates, and it is simultaneously a time. It's a clock. It's a clock and a model of rotating Earth. He combined both functions, and as usual, his description is a single shloka, very cryptic. He just says, make a spherical wooden globe,
Mhm.
uniformly dense and light in weight, and using mercury, oil, and water, and applying one's own intellect, make the globe rotate at the required rate to keep pace with time. So this means you must make the globe rotate at the same rate as Earth.
Mm-hmm.
And his commentator, Suryadeva,
Mm-hmm.
Suryadeva gives a very detailed description. So it is from that description that we have drawn the picture.
Right.
So what it does is that there is a
Mm-hmm.
tube filled with water, and the tube has a small hole at the bottom, and there is a weight. Okay, that weight has a little mercury inside to add weight and to stabilize it,
Mm-hmm.
and this is tied to a string, and that string winds over a wooden globe, and that globe rotates on bearings, two bearings. So this is adjusted such that when the water flows down,
Mm-hmm.
this slowly goes down. This weight goes down.
Right.
When the weight goes down, what happens? The
Globe.
thread unwinds
Right.
and the globe rotates. And things are so adjusted that the globe completes one rotation in
One day.
60 ghatis.
Mm.
60 ghatis means 24 hours.
Right.
So that was how this was made. Such an ingenious thing.
Yeah, absolutely. And I should tell the audience that Gati was the unit of time measurement at the time, which is, I think, approximately 20 or 24 minutes from what I remember.
Yes,
And it
24
is
minutes, I think.
24 minutes, yeah. So for 60 ghatis, and then you are saying, okay, just like we have hour today, we have ghatis at the time. Instead of
Yes,
saying it's a 24-hour day, we are saying it's a 60 ghatis day. And so he's able to say that, he's able to rotate that globe or that gola within those 60 ghatis exactly, to be able to say, okay, this is how the earth is rotating. So I feel like this is again very easy to recreate by anyone who has these couple of things and try to test his theory and understand in like whether this is true or not. And I think Mahesh Shastri is saying ghati is also called nadi in
yes.
Sanskrit. Oh,
Nadi in Sanskrit.
nadi. Okay, now let's talk about day and night, because he knew that Earth is rotating.
Yes,
He knew not just that, but he also knew that it's rotating around a tilted axis. So
yes,
I think that's again mind blowing for me at the age of 23. He knew
yes,
so many things. But
yes.
let's talk about that tilted axis
Yeah.
and how he's talking about that in his work.
And why do we say that? Because he says in verse 17 in Golapada
Hmm.
that there is 6 months day and 6 months night at the poles, which is
Hmm.
correct.
Yeah.
So that can happen only if the axis of rotation of Earth is tilted. Otherwise, it will be just 24 hours, means 12 hours day and 12 hours night. So when he says that, and he didn't go to the poles. Of
Hmm.
course, I went to Arctic Circle. That's my picture with
Yeah.
my wife. But in those days, I don't think Aryabhata could have gone to the poles.
Yeah.
So he did this by his observation and by his intellect. So he knew that the Earth axis is tilted.
Hmm.
Then he knew other things. He said that the uh, uh, night and day
Hmm.
on the moon 14-day night and 14-day day, means 14-day dark and 14-day light.
Right.
How did he know that? So
That
it's
is.
all calculation and observation.
Yeah, I think it's a lot more observation than what you and I would think about, Radhakrishna ji,
Yes,
because I feel like the fact that moon completes its revolution around Earth in that 27 to 28 days approximately,
yes,
and when it's doing that, it's exactly the same side that is facing us actually.
right,
So you can think of it as Earth completes its rotation around itself in 24 hours, where we are getting some part is day and some part is night. Moon completes the rotation around itself in 27 days. So that
yes,
is why there is half of the time, or 14, around 14 to 15 days approximately, there is night on one side and day on the other side, and other way
yes,
around. So you can imagine, like, sitting on Earth, I don't know how he knew this, and without
yes,
having telescope or any of those instruments, from what we know, I don't think he had access to anything like that, and yet he knew clearly that that is also the case on Moon. This is again. I would say if I were existing in his era, I would probably be a fan following. Arya. Okay, so I think we've talked about rotation. Let's also talk about revolution part from Aryabhatta.
Yeah. See, so we know that Earth has two different movements. One is its rotation
Yeah.
about its axis, and the other is its revolution around the sun. So revolution is a 1 year period thing.
Mhm.
Rotation is a 1 day period thing. So most pre-modern astronomies, they did not know about the rotation of the Earth or its revolution. Okay, but Aryabhatta knew about the rotation of the Earth. He mentions its speed and all that, but he does not mention the revolution of the Earth around the sun, probably for his own reasons. I don't think that such a bright astronomer would miss that,
Yeah.
but we don't know. Maybe he mentioned it in some of the works that did not reach us.
Mhm.
So he had to use again all those epicycles and all those things.
Right. Yeah. So he's using geocentric. I am a firm believer that he knew about heliocentric model as well.
Yes.
I think he had his astronomical observatory set up around Patna. There is a small village where they say his observatory was there, and I feel like his work, which we lost, which is the Aryabhata Siddhanta, it was based also on Surya Siddhanta. So
Yes.
from what I know, so I think he was aware of it. Either he mentioned it in his later on work, but we lost that work unfortunately, so we can't say for sure today. But just like you, Radhakrishna ji, I firmly believe that he also knew about
Yes.
heliocentric. What is important from Earth, though, is how it appears from Earth. So,
Yes.
for most of the calculations that we have on astronomy, we are interested to know more about what is appearing to be from Earth, and so I think
Exactly.
focus is on that over here. Okay, so let's talk about that geocentrism,
Yeah.
heliocentrism, or more specifically also the cycles that he's, because I think
Yes.
even though the planets are rotating in observed from Earth also, if you think that planets are rotating around Earth, even then I think their path of or the orbit is extremely complicated to explain.
Yes.
Let's come.
Yes. Yes. So, and one interesting thing is that, see, both the Western astronomers and Aryabhatta used this epicycle and all that, but Aryabhatta's methods were more accurate. He could, uh, what do you call, say about the position of the heavenly bodies much more accurately than the Western astronomers. And one thing is that his uh, model is pulsating epicycle, means uh, its diameter varies, whereas in the case of Western astronomers, everything was fixed.
Mhm.
In other words, Aryabhatta used a dynamic model,
Yeah.
and whereas Western astronomers used a static model.
Yeah, let's talk a bit about that to explain. I think this will
Yeah,
explain a little bit more on what an epicycle is.
yeah,
So this, to be honest, it looks like a very simple rangoli to me. I'm not sure if the rangoli is inspired from the epicycles of Aryabhatta, but let's talk about what he's talking about in this particular slide.
yeah. Actually, epicycle is a small cycle riding over a large circle. The center of the small circle moves along a bigger circle. So the heavenly bodies are supposed to be doing to be on the small circle.
Mhm.
So it is their path that is shown in the thick circle in the diagram. So they are moving like this. Okay,
Mhm.
looks strange, but
Yeah.
this yields correct results. So for the ancient people, the results were more important. So this and this was the same thing the Western astronomers also used.
Mhm.
Only thing, Aryabhatta, as I said, used pulsating or dynamic model, and his big circle was not exactly a circle. He
Mhm.
used an ellipse, so that's why it's called eccentric circle.
Right.
So he used an ellipse or an eccentric circle, and
Mhm.
that yielded better results. And interesting thing is that when we look at planets from Earth, sometimes they seem to go in the other direction.
Yeah.
They retrograde motion. Retrograde means backward motion, which in Sanskrit is called Vakragati.
Mhm.
So you can actually explain Vakragati also here. Say from 2 to 3,
Yeah.
the planet is moving backward.
Yeah. Makes sense. So what we are trying to say is, the planet is roughly moving around this circle out here, but its movement is not as smooth as a circle, basically. So instead of going on that path directly, it's actually moving like that on the
Yes,
circle.
yes,
And so what happens is when it's moving like that on the circle, from point 2 to 3, it appears like, oh, it's going backwards, but in fact, it's eventually going to go straight on that.
yes,
And so I think this concept of vakra is also in astrology or jyotish shastra, what we say, whatever snapshot of sky you've captured, let's say it's janma kundali or the time of your birth, if a certain planet is shown in minus or negative, then that was appearing to be in retrograde when that person was born. So it's heavily used in astrology as well. But the fact that, again, they knew that the planets are not in the perfect circle, moving in perfect circle as we think of it, but instead the path is very fuzzy. It's still around that path, roughly, but not exactly. Something like that is insane to know. Sitting here on Earth, I really wish I
yes.
was, alive back then and knew more about how did they know about it. So this one I think explains more
Yeah,
accurately
that
what we're talking about,
yes,
and this is how the planet is moving roughly on a elliptical path, but not
yeah,
exactly elliptical. It's kind of going
yes,
fuzzy like that.
yeah,
So orange
like this.
path,
Yes,
yeah, orange path is how the planet is moving, but we would think
yes,
that the gray circle that is within that orange path is how the planet is moving, is what we think. But actually, it's moving like this. So this is again very crazy to know from Earth. Okay, so let's talk about Earth and planets and how. So I think he was also the one to point out that Earth is getting its light or it's getting illuminated from sun, and so are
yes.
the other planets. So let's talk about that a bit.
See, Aryabhata said that all heavenly bodies are golas, are spherical.
Right.
And what he says is that halves of the globes means half side means half of the globes of the Earth and the planets are dark due to their own shadows. Means they are not facing the sun, so
Right.
they are in the shadowy region. The other halves facing the sun are bright in proportion to their sizes, of course. So what he essentially says that all heavenly bodies are shining not because they have light,
Yeah.
but because of the reflected light from the sun, which is true. We know that.
Yeah. Now we know that.
Yeah.
And I think also, no wonder that he knew about the sun giving us all that light. He also knew
Yes.
about how eclipses are happening. So this one is extremely complicated to know, especially now we know eclipses, obviously, and
Yes.
we know everything and how it happens. But back then, again, you are only having observational astronomy at hand and your mathematics as the support, and you still know about what causes the eclipses. Now that's again huge, right?
Yes. Exactly. See, Aryabhatta very clearly mentions
Mhm.
that eclipses are caused by the shadow of the Earth and the Moon. When the shadow of the Earth falls on the Moon, it is a lunar eclipse,
Yeah.
and when the shadow of the Moon falls on the Earth, it is solar eclipse. And also, he says that time means when they happen. That is, at the end of a lunar month, the moon lying near a node. Near a node means it should be on the ecliptic. See, the moon's orbit is 5 degrees
Tilted.
inclined.
Yeah.
So only when it aligns with the sun,
Hmm.
when they are in what do you call uh,
Conjunction.
conjunction,
Mhm.
then only eclipse can occur. So when it is lying near a node, and at the see at the end of the lunar month, So when the end of the lunar month is is when the new moon or the amavasya occurs. So then the lunar eclipse occurs, and the solar eclipse occurs at the full moon.
Right.
So that is in mode. So he says when at the end of a lunar fortnight,
Yeah.
end of a lunar fortnight is when the full moon happens. Sorry. So he exactly says when it occurs
Yeah.
and why it occurs, because of the shadow.
Mm.
And,
This is
and
this is again crazy to think, but then that also means that he knew about the tilted path of moon. Otherwise, every Purnima and every Amavasya would have eclipses,
yes,
right? But he is
yes,
aware of the fact that the moon's orbit is also a little tilted, and so it has
yes,
to be in conjunction with the sun for the eclipse to occur. And
yes,
so, if he was giving methods of calculating that as well, I think
yes,
that is even more precise to know
yes.
when the eclipses would happen.
See, actually, till about the beginning of the 19th century, so even in the 1800s, our prediction of eclipses were more accurate than the Western ones. Even English men have recorded that. I read about a collector's observation. Means those days collectors were British people.
Yeah.
So this collector had actually both. He had the eclipse time and eclipse prediction from a
Mhm.
local astrologer. Means those days astrologers and astronomers were one and the same. So he got that from a local astrologer who used Aryabhata's calculations, and then from a Western astronomer. And
Yeah.
that collector says that the Indian thing was more accurate.
Yeah, talking about having an influence that transcends lifetimes, you can imagine that someone would think, okay, I might have an impact for 2 to 3 generations after me, but this is like 1500 years
Yes,
after his era. He has an impact on calculations of so many things that we know today. Again, want to highlight to the audience the genius of Aryabhata, because we only know him for, like Radhakrishna ji said, zero or nothing. But there is so much more in his work of Aryabhatiya that we deprived ourselves of all these days. We should definitely go ahead and read that. So, talking about eclipses, I think there's also a concept of Vyatipat. So, what is
yes.
Vyatipat, Radhakrishna ji?
Vyatipat is actually refers to the point where the orbits of the sun and moon appear to intersect. Moon at 5 degrees, sun,
Mhm.
and when they intercept, when they what do you call when they cross,
Yeah.
that is called a Vyatipat.
Okay.
So, in order, yeah, as per astronomy,
Yeah.
Rahu and Ketu are the moon's nodes. Yes, exactly. So
Yeah.
that is when that aligns with a new moon or a full moon, we
Mhm.
have got the eclipses.
Right.
And Aryabhata has given the calculation methods very clearly. It is deep trigonometry.
Mhm.
So uh, those methods worked very well for all these 1500 years.
Yeah, and I think there is. I mean, we think of Rahu Ketu as some demons, because of the way that we were taught about Samudra Manthan, and there was a
Yeah.
demon who was Rahu Ketu at the time. There was only one demon, and then Vishnu beheaded him, and the head part was Rahu, and the tail part was Ketu. Actually, all of this I feel like it's infotainment, right? You need to
Yes.
remember Rahu and Ketu. So to because they don't exist. I cannot point in sky like I could point to a sun and say that this is Rahu and this is Ketu. So these are the 2 points, and modern world knows them as dragon's head and dragon's tail. By the way, these are two
Yes.
nodes or 2 points in space which are on the path of moon. And so we say that when Rahu was the one who when the demon was drinking the amrit, and he was posing to be deva. There was sun and moon who kind of pointed out that this is not a deva and he is drinking the amrit. And so I think Rahu was the one who said, okay, I'm going to be after sun, and Ketu was the one who said, I'm going to be after moon. So the point when the nodes are inclined or they are aligned, on the node of Rahu, that is when the solar eclipse happens.
Yes.
And when they are aligned on the point of Ketu, then the lunar eclipse of. Now, I
Yes.
also didn't know this, but I think I remembered it because of the infotainment.
Yes.
Because
Yes.
I knew about the
See,
story of Samudra Manthan, you know.
yes, yes.
Uh,
See,
and
actually, these stories are interesting, and they actually serve to keep these things in the mind.
Mind, exactly. So I wouldn't forget now, like when solar eclipse happens and when lunar eclipse happens. And so I think that's the point of infotainment. But that apart, I think this is where Aryabhata has mentioned Vyatipat, where these have to be aligned. They have to
Yes.
be on that note to be able for the eclipse to occur. Otherwise, like I said, every full moon day and every new moon day would have been an eclipse, which is not the case.
Yes.
Okay. So let's talk about the most interesting part from Aryabhata, which is pi. Now, again, I don't like, for a lot of things, we end up saying that we already knew this. I don't think pi was defined by Aryabhata like 22 by 7. But there is another calculation that he has, which is the value of pi itself, and he has extensively used it. So let's
Yes.
hear about that from Radhakrishna ji.
See, Aryabhata has a very accurate value for pi. He
Mhm.
says that we get pi by dividing 62,832 by 20,000. Okay, and that gives pi as 3.1416,
Yeah.
which is much more accurate than 22 by 7.
Mm.
But he also says that it approaches the value of pi. It is not the value of pi. It approaches asanna. It is asanna. Something is asanna means something is approaching. So
Right.
he exactly uses that word asanna.
Mm.
So a later commentator, Neelakantha Somayaji,
Mhm.
points out that he says, Acharya says that it is asanna, which means, which implies that the value is irrational. An
Mm.
irrational quantity is something which cannot be expressed as the ratio of two integers. Okay,
Yeah.
so Aryabhata knew that. Aryabhata knew that pi was irrational.
Yeah.
So he says that his value 3.1416 approaches the value of pi.
Pi. Okay.
So both he
Yeah.
knew pi and also he knew that it is irrational.
Right. And I think it's also important to point that out, right? Because it's not accurate. So unless
Yeah.
someone like him says that it's not accurate, otherwise people might just blindly start following that this is the
Yes.
accurate value and then taking that. But he's more specifically saying that it's approaching that value and not
Approaching.
exact.
Also, this prompted others to find more accurate values, like Madhava of Sangamagrama. See, later in Kerala, is Kerala School of Mathematics developed from 1300s to 1600s.
Yeah.
So Madhava was the initiator of that school,
Mm.
and he calculated it using calculus.
Okay.
See, Madhava of Sangamagrama actually used calculus long before Newton. Means we just study in textbooks that calculus. Newton was the what do you call
Yeah.
inventor of calculus.
Yeah.
No,
Yeah.
so Madhava of Sangamagrama used calculus
Yeah.
long back.
Mhm. Yeah, makes sense. I
So
think this is where we are highlighting all the people who have been great mathematicians in India.
yes,
And thanks to you, Radhakrishnan, for being able to talk about
mm,
the precise locations where we're picking this from. We are not just saying that we had it; we are also putting the verse, and we are saying this is what shows that we had it.
yes.
So I think that's very, very important. Uh,
Man, instantly pie reminds me of pecan pie, which I
ah,
like very much. There's a
yeah,
vegan pecan pie,
yeah,
which doesn't use eggs.
yeah.
That's wonderful.
I think I myself enjoy pecan pie, and I also like it that my family does not like it because I can have the whole thing when I get it. Uh,
That's
Everybody else hardly eats, so I'm kind of selfishly happy about that. Okay, again, another genius of Aryabhatta is the fact that
yes,
he calculated the diameter of Earth. Now,
yes.
I think there was slight error in that, and I'll request Radhakrishna ji to explain that error
Yes.
as well in his calculation.
Actually, Aryabhatta measured the diameter of Earth
Mhm.
using the shadow, the Nomon shadow method. So what he did, on the same day of the year at the same time, he measured the angle of the shadow or the length of the shadow at two different places.
Mm.
It doesn't mean that he measured it on the same day. So 1 year he measured, say 1 year, let's say March 31, 12 o'clock or whatever time. He
Mhm.
measured the shadow at, say, Ujjaini, and then, or maybe in Patliputra, and then on the same day next year,
Mhm.
he measured, same day, same time next year, he measured the shadow at another place on the same longitude,
Mhm.
maybe a 100 or more kilometers away.
Mhm.
Okay, so from these two measurements, we can calculate the circumference of the Earth. Means it's a trigonometric thing. It is easy, but the problem is that calculate means measuring the distance between two places is not that accurate. Means you cannot have a tape and measure, say, from Patliputra to another place 100 miles north.
Yeah,
So you just guess, means how much time a horse takes to travel from this place to this place. From
right.
that, you,
Know the distance.
yeah, know the distance. So he took that distance and calculated, and his calculation is 14,112 kilometers. Of course, he doesn't use he did not use kilometer.
Yeah.
He measured it in yojana,
Mhm.
and he said the Earth's diameter is how much? 1,050 yojanas, he said. So one yojana,
Mhm.
and he defines his measurement.
Yeah.
One yojana is 8,000 nr. Nr means human being. Means average human height.
Mhm.
So even that is defined. See, first definition is angula. Angula means a finger.
Right.
So he says 24 angula is one hasta. We
Okay.
know from modern measurement, one finger is approximately 1.75 centimeters.
Okay.
So one hasta, and four hasta is one human being's height. So if you calculate that way, 24 multiplied by 4 multiplied by 1.75, so
Mhm.
the average is average human height is 168 centimeters, roughly 5 foot 6.3 inches.
Mhm.
That could be the average, because there are short men, there are tall men and all that. So average might have been those days
Yeah.
5 foot 6 inches. So from that, 8,000 nr means 13.44 kilometers. So if the diameter is 1,050, we can calculate
1,015 to
that as 14,112.
12.
And from the diameter, you can calculate the the circumference.
Right. Because
That
again,
is five times the diameter.
right. Because he also knew, I think, about the spherical trigonometry, like you said, we'll talk about that. But
Yes,
he knew that he could calculate that diameter of the Earth. So also
yes,
let's talk about spherical trigonometry now. So we have this concept of trigonometry, which is the word in equivalent word in Sanskrit is trikonamiti. So
yes,
it sounds very, very similar,
yes,
trigonometry and trikonamiti. And so let's
yes,
talk about the values of sine and cosine and how he
yes,
arrived at those values. It's a funny
yes,
story and a language mix, but
yes.
let's talk about that.
See, in astronomy, we have to use this cos, sine, tan. Those who studied trigonometry will know that what is cos, what is sine, what is tan, and all that. So that is extensively used in astronomy. And in the olden days, they had to find the value. See, right now we have the values. Somebody, intelligent people, found it for us. But in the olden days, they had to find. So they made all tables and all that. So now, how did the English word sign originate?
Yeah.
And it has originated from the Sanskrit word Jia.
It,
Jia means a, what do you call it? The string of a bow.
mhm.
So sign is ardhajya. We'll come to that in the next slide. So
Yeah.
sign is ardhajya, half jya.
Mhm.
And when Arab astronomers translated Aryabhata's works, they did not translate the word jia. They simply used it as it is in Arabic, but they distorted it. Of course, when you hear sounds, it gets distorted. So they wrote it as jiba. Okay, jia was written as jiba, and in Arabic, when you write, you can actually show the vowels, but normally they don't show the vowels. So
Okay.
when they wrote jiba, they did not show the vowel sign for e,
Mm.
which is a slanting line under the jim, the ja, the the character with the three dots, because that is Arabic is written from right to left.
Yeah.
So they actually left all these vowel signs and wrote it as ja, ya, ba.
Mm.
Okay. Now, 2 or 3 centuries later, Europeans came and they translated the Arabic into
In
Latin.
Latin.
So when they saw J, ya, ba, means JYB, they thought that it was Jaib.
Pocket.
Jaib is the Arabic word for pocket,
Yeah.
for a pocket. See here, a shirt pocket or a whatever.
Yeah.
So the Latin for a pocket is sinus. So they translated it as sinus, and
Yeah.
that sinus became sign in English, and it
Yeah.
was abbreviated as SIN, sign again, sign. And
Mhm.
then this Gia and Kotijia is cosine. It's
Mhm.
also abbreviated as Kojia. So Gia and Kojia became sine and
Cosine.
cosine.
That's a very, very long journey for a word, I would say.
Yeah.
And also
Mhm.
now the disease of sinus also makes sense to me because they call the pocket within the nose as sinus.
Yes.
If you have like issues there, it's called as sinus issue. So that also makes sense that Latin word for pocket is sinus, and the ja
Sinus.
from Sanskrit got translated to jab somehow,
Yeah.
and then that jab got became sine and cosine.
Sinus.
So ja and kotija are the units that Aryabhata has used. All
Yes.
right. So I think this one is explaining like
Yes.
sine and cosine. It's also explaining R sign, which is more specific to Aryabhata's work.
Yes. Our sign is used in our Indian astronomy and also Western astronomy. So if you consider a bow, ancient bow and arrow. So if you superimpose that on a circle, you get this figure.
Mhm.
And here, if it is a unit circle means its radius is one.
Mhm.
Assume that its radius is one, then you can say that this half uh, cord means half the length of the string
Mhm.
that uh,
Ja.
connects the bow. That is sign of that angle. So this is called jya. In Sanskrit, this string is called jya.
Mhm.
So sign is ardha jya, half jya.
Right.
That's what is shown in the bottom, that derivation. And in astronomy, we don't use just the sign, we use R sign.
Mm.
So see here, it is a circle with unit radius, but we can choose any radius.
Mm.
So Aryabhata chose a radius of 3,438. Means
Yeah.
the R was 3,438. Why did he do that?
Yeah.
Because the 3,438 is the minutes, if you corresponding to 1 radian. See,
Yeah.
we can measure angles in radians and also angle and also degrees. So 360 degrees is one circle,
Right.
and it is same as 2 pi radians.
Mhm.
So how many degrees are there in a radian? So
Mhm.
you divide 180 by pi. 360 by 2 pi or 180 by pi is 1 radian in terms of degrees. Now, they wanted still more accurate, so they chose to express it in minutes. So
Mm.
we know that 60 minutes make 1 degree. So 180 multiplied by 60
Mhm.
divided by pi, which is 3.1416, gives 3438. So that's why uh, Aryabhata used R sine value. So when they say R sine of an angle, it is sine theta multiplied by 3438.
Yeah, it seems like an odd number to use, but its derivation makes much more sense now.
Yes.
Why it's being used. So this is amazing. I think he also came up with sine tables, and so
Oh, that,
within so let's not go
that
too deep into the calculations of sine tables, but I wanted to understand, like I wanted the audience to understand how he separated those sine tables. He did it in 24 segments, and then he
yes,
calculated for each segment what the value for sine would be. So considering
yes,
that, this is the radius and this is the angle that that the line is making, then
yes,
within this much, what would be the sine value? So that is what he
yes,
calculated, and then he
exactly.
divided it into 24 parts.
A table, and this table is so means it was what do you call such a path breaking thing.
Yeah.
Uh, that this table was the first ever constructed table in the world of sine, because even they did not know what a sine was.
Was.
Now Aryabhata defined a sine,
Yeah.
he defined r sine, and then he created
Yeah.
a table of these values. So he generated it for one
Got it.
quadrant, and from that easily we can calculate the other quadrants.
Right. This is
So
actually
ye-
groundbreaking. This is like someone is serving me everything on a silver platter. And I
yes,
enjoy.
exactly.
Awesome. So, huge thanks to Aryabhat for coming up with all of these calculations. I think here
Yes,
he has given it a unit, basically Makhi Bhakhi. I think this is
yes,
sounds funny, but I think he's given the name for each of the degree minutes
yes.
and his calculations accordingly.
Yes, yes. These are representations of the number. So
Mhm.
on the right, you can see how that is done.
Yeah.
We have a next slide shows the correspondence between these words and the actual numbers.
Yeah.
So again, it's a place value thing,
Mm.
and yeah, this table.
Yeah.
So this table actually uh, shows the correspondence between the characters and the numbers.
Yeah, I think what he's done here is kind of used encryption because
Yes,
you can imagine you can represent 10 or 10 raised to 1, 10 raised to 2 pretty easily.
yes,
But if you have to represent like 10 raised to 17, for example, that's an insanely large number, and who is going to write it
yes,
every time? So he kind of came up with a method of being able to represent very big numbers using letters very, very
yes,
precisely. So I think that's one of the examples. I think quickly explaining Makhi is ma
yes,
plus a. And so ma
yes,
here in this table, if you try to find it, is a value of 25. And then a here, correct me if I'm wrong, Radhakrishna ji, a is
yes.
basically
You're
10
correct.
to 0. So 10 raised to 0, and this is ma. So ma is the first part, which is 25 into 10 raised to 0. And then he is a combination of h and plus e. So basically,
Yes,
h here is in the table, it's 2, and e here is 10 raised to 2. So that is what we are coming up with. And then that
yes,
becomes 2 multiplied by 10 raised to 2. So 200 plus 25, which is 225. And
exactly.
kind of shown as an encryption. So
Yes.
you can imagine that he kind of it's like smartly he used the letters instead of
Yes.
having to represent the numbers every time. That makes sense to me, obviously, because I don't think I would also represent such a long number every time.
Yeah, it is difficult. Also, you have to represent the numbers in verse, in
Okay.
poetry, in a shloka. So
Right.
this is the best way.
Right. So these are the names that he has used for the sign table, as you
Yes.
here makhi, bhakhi. And so if you had that table in front of you, you could calculate that value and arrive to the same conclusion,
Yes.
basically. Okay, so I think this is interesting because he's given the decimal places of up to 10 here within one shloka.
Yes.
That's pretty amazing as well. That's like, I think,
Yes.
gone up to a billion or a thousand.
Yes. Yes.
Yeah, he's gone up to a billion. So ekam dasham cha shatam cha sahasram tvayuta niyute tatha prayuttam kotya kotyarbudam
Your Buddha.
cha vrundam sthanat sthanam dashagunam syat. What he's saying is each of these numbers are multiplied by 10 apart, basically.
Exactly.
There is
Mhm.
Ekha, which is units place, then Dasha, which is tens place, then Shata, which is hundreds place, Sahasra, which is thousands place, Ayuta, which is 10,000 place, Niyuta, which is 100,000 place, Prayuta, which is millions place, Koti, which is 10 millions place, and then Arbuda and Vrunda, and then these are respectively 10 multiplied by 10 apart from each
Yes.
other. That so within one shloka he has given up to a billion numbers count.
Billion. Yes.
This is great. Okay, so not just that, I think Radhakrishna ji, he also in Ganita Pada, he is talking about much more
Yes.
mathematics than zero. I think he's
Yes.
talking about quadratic equations and how to solve
Yes.
them. So whoever is interested, you can check out these shlokas from Ganita Pada. Here are the shlokas, and then we also have the verse number. Radhakrishna ji has precisely
Yes.
also given the verse in which he's mentioning that. So you can see he has mentioned how quadratic equations can be solved. He's also mentioned about square and cube roots, right, Radhakrishna ji?
Yes. Yes. Yes.
So that also means that he's talked about the expansions of a plus b bracket cube or a plus
Yes.
b bracket square. And
Yes.
this is like the verse in which he's again mentioning those specific details. Obviously, I think the shlokas might be very hard to interpret, but like Radhakrishna ji said, there are commentaries on it, and they
Yes.
go a lot more into detail of what that verse exactly means, and you can try to understand it.
Right.
And not just that, I think he's also talking about simultaneous equations of one
Yes.
unknown, which is uh, single x, basically,
Yes.
and coming to the conclusion of how you can find the value of that unknown x. So I know that
Yes.
you look into the modern mathematics, what do you say, like representation, but from his shlokas, you can come to the same conclusion that you would come today with the mathematical representation.
Exactly.
Radhakrishna ji. Okay. And then we also have, so that not just, I think, not just one unknown, but he has also gone
Yes.
to n unknown, which kind of
And yes.
it sounds a little crazy, but he has also given equations for simultaneous equations with n unknowns, and then you
Yes.
can also come to each x1, x2 up to xn values from his shlokas.
Yes.
This is something interesting, Radhakrishna. You should talk
Yes.
the kutaka. So this looks something like in the kitchen, but there is seems like Aryabhata has used it in a very creative way.
Yes. See, this is used for powdering things, making powder. Say, if you have elaichi and you put it and then
Yes.
you get elaichi powder.
Yeah.
So uh, Aryabhata says that solving the equations such as ax plus by equals c,
Mhm.
you use this method. You break that into small parts, kuttaka, and he gives the solution in verses 32 and 33. It is very succinct. So this link gives you the method in detail
Yeah.
of how the kuttaga methods have been explained by others also, like even our Bhaskaracharya too
Mm.
mentions kuttaga methods. So kuttaga was a very favorite of our Indian mathematicians.
Yeah, I think I am also very curious to find out what this method exactly is. But it's also giving you equations like ax plus by is equal to c, where a,
Yes.
b, c are the known quantities, but you're trying to find x and y. So I'm now curious
Yes.
what did he use differently, and such a creative name also that you're trying to break it down.
Yeah.
So Kutaka method, yeah. So anyone who is interested, please go and find out more about this. I'll also give a link to this one in the description in a little bit. I think he's also talked, astonishingly, Radhakrishna ji has also talked about the series, right? Like the
Yes.
progression.
Yes.
Then
Progression. Exactly.
he's talked about progressions. He's talked about areas and volumes, like
Yes.
a circle for a triangle. Trapezium just stands out to me because why would they be using trapezium for something? Very curious. But he's also talked about the area of a trapezium
Yes.
in verse 8. And he's also given its correct value. So
Yes.
this is where I think our like chat or conversation is coming towards an end. So, do you have any concluding remarks, Radhakrishnan ji? This work is, much more than what we think of Aryabhatta. When we hear the word Aryabhatta, what comes to mind?
Yes, because he made means his things are actually groundbreaking. Whatever he did is, say, for us it seems now, oh, simple, oh, sine, cos, but he came up with the definition. He calculated the values. Similarly, rotation of the Earth. Now it is simple thing for us, but he conceived it.
Yeah.
He conceived that the Earth's axis is tilted. All those things means these are all groundbreaking things. These were groundbreaking at his time. They were revolutionary findings at his time, and his methods were used till the modern times. I think even the panchangas back in Kerala, even in my childhood, I have seen panchangas, uh, printed panchangas, means we used in our household
Mhm.
panchangas, and those were actually calculated using Aryabhata's method. And again, the prime meridian was Ujjaini
Yeah.
in those, and they actually write those panchangakaras write prime meridian is Ujjaini, and
Mm.
then they of course later they give times for other places, but uh,
Right.
essentially they used Aryabhata's methods till as recently as my childhood.
I think I'm sure Pandit Mahesh Shastri ji would also know more because he is a Panchang Siddhanti as well. So the methods that he learned to be able to calculate all these when he was growing up, I'm sure that also has been influenced from Aryabhatta. And it is my
Yes.
personal wish that someday, just like we have Griffith Observatory today, we should have a Aryabhatta Observatory
Yes.
where we kind of pay tribute to him and we say
Yes.
that this we acknowledge that he was one of the greatest astronomers that India had. Many more after that as well, but I think, like you said, his work was the groundbreaking one, and his calculation and his work has been used by so many astronomers after that. Not just astronomers, even the modern day 19th century, 18th century folks have calculated the eclipses to the correct value. There is so much that we have gained from him that I feel like we should definitely have an observatory in his name,
Yes.
more dedicated to talking about him as well as his work, and then explaining to people how you can use his work today. So that's great. And this is the references list that Radhakrishna ji promised you. I think he's made it very,
Yes.
very concise
Mhm.
here. We'll be sharing all of these links in the comments section in a little bit, but I'll also add it to the video description once we are done with the live stream. So all of these details are here for you to go and start reading, knowing more about Aryabhatta. And lastly, we should, instead of Radhakrishna ji thanking us, I think we thank you, Radhakrishna ji, for having
Mhm.
all of this information, I think, again, concisely put so that the viewers would understand it. And also the fact that there is so much to fathom about Aryabhatta that it's almost impossible to fit it into like 1.5 hour session and talk in so much detail about him. So thank you for, putting this information together for us, and also explaining everything by breaking it down, because I think that's the hardest part of teaching anything is breaking it, Kutaka method, breaking it down.
Mhm.
So
Breaking
thanks a bunch.
breaking it by Kutaga.
Exactly. So thank you so much for doing it. And for audience, I would say if you liked our session today and the content in it, please hit a like. If you've liked it, please share it with your friends and family. If you have any questions and want to reach out to us, please comment. And also don't forget to subscribe so that we can keep bringing this beautiful, detailed content for you. And thanks again, once again, Radhakrishna ji.
Yeah.
Let's
Thank
end the
you.
live stream here. Thank you, everyone.